Hi, I'm Ara, N6ARA, and welcome to part 3 of the TinyGawant antenna series. Now, if you haven't seen the last two episodes, here's a super quick refresher. Over the past few months, I've been designing and building on this antenna here called the TinyGawant. It's a small QRP whip antenna with a tuner built in and an SWR indicator that lets you tune up anywhere from the 10 to 40 meter band. Today, I'm excited to share that the final version of the TinyGawant antenna, Rev C, is complete. And so today we're going to go into what went into iterating on this design and getting it to the level of being ready for production. But before I do that, I kind of have to address the elephant in the room. Now you may be wondering, what took you so long to make an update? It's been 7 months since the last episode dropped. I mean, did it really take me 7 months to iterate on this design? Well, the answer is kinda. Let me explain. In the last episode, I claimed that the counterpoise actually hurt the performance of the antenna. And while I claim that, it really was just that. It was just a claim. I'd only based that off of a few small observations I made in the field while trying to make contacts with it. However, something just didn't sit right with me. I couldn't believe that adding a counterpoise to an antenna system like this could actually hurt performance instead of help it. It just went against every theory of operation I knew about antennas, and I kept kicking myself as to why would this antenna be different? And this problem ate away at me, to the point where I decided I really need to dig into this and learn more. And really, at the end of the day, it comes down to you can either simulate it to prove that it either helps or hurts it, or you can actually build a system that lets you test the antenna with and without a counterpoise to see if it truly does make the antenna better or worse. Now, funny enough, it was around this time my buddy Rob, K6KM, reached out to me and said, "Hey, I've actually simulated this antenna. Would you be interested in taking a look at the results?" And of course, I had to say yes. Now, Rob was kind enough to send me the simulation files to help me get started with simulating this antenna. In his sim, he had modeled the LC match with a whip antenna and had gotten some really interesting and insightful results. For one, it confirmed that the antenna with just the whip does radiate, but it does not have much gain. Secondly, he showed that a lossy core is actually required for this antenna to even work. If you use an air core inductor, the system simply would not tune it. You just get high infinite SWR. So this antenna really does act mostly like a dummy load. And after understanding the setup of his sim, I tried to add a counterpoise and found that it actually helped the gain, but that didn't seem to align with my observations in the field. As I dug into this more, I learned that the feed point itself wasn't quite representative of how the antenna is actually fed with the matching unit of the TinyGawant. Furthermore, I realized that the simulation program itself is constrained to feeding the antenna network at a specific point, and that you can't exactly define a matching unit with an RF input and ground conductors. After digging into it some more, I realized I needed a much more powerful finite element modeling tool like HFSS, but quickly learned it's actually quite an expensive program even for startups. Now, I was about to give up on the simulation entirely when I learned of a new program called Emerge. This is a finite element modeling tool just like HFSS, but it's free, open source, and Python based. The downside, however, is that it's not as mature of a program as HFSS, but it looked like it could do the job. After digging through the documentation and learning how to use the software, I was able to get a basic model to work, but I quickly realized just how hard it would be to set up the model and to validate the results. As those who have worked on simulations know, the more complex a model becomes, the harder it is to validate and trust. While I would like to have worked on this simulation some more, I realized that I was just essentially spinning my tires for weeks just trying to learn how to use the program and understand antenna modeling. But I really needed some trustable performance results, and I needed them soon. Now, at this point, I realized I needed to switch gears. No more simulation work. We really should actually build a system to prove one way or the other that adding a counterpoise either helps or hurts the antenna. And it turns out this was a major rabbit hole. I ended up spending months designing, developing, testing, and eventually proving if it helps or hurts the antenna. After all that work, the answer is it helps the antenna. Like, of course it helps the antenna. I don't know how I was able to originally convince myself that it hurt the antenna's performance, but the truth is it actually helps the antenna by quite a bit, like 6 to 15 dB. Now you may be asking, how on earth did you even prove that? What evidence do you have to make that kind of claim? And I will say, I have about 500 gigabytes of footage of me designing, developing, testing, and proving this. However, I could not fit it into this episode. I did a quick rough cut and it turned into a 3-hour-long documentary, and that is really difficult to consume. So instead of doing that, I decided this episode here, we're going to close out the TinyGawant design and essentially get it out into the market as a kit. And at the same time, I am also editing, as we speak, a multi-part series on how I developed and designed this system. Now, as a quick teaser, I gotta at least show you the hardware. I'm calling this project the Antenode. Antenna and node together, they make antenodes. This system I've devised can actually test the relative performance between 2 or more HF antennas. And the longer you run it, the better the statistics get. I can't wait to share this project with you all. It has consumed so much of my life right now, but it's going to be really exciting, and I really believe it's going to change the way we test the relative performance between 2 or more HF antennas. So stay tuned, lots more to come. Now, with the counterpoise stuff aside, there is one remaining mystery with this antenna that has been bothering me, and that is, why am I unable to make a single 40-meter contact with it? It can tune up on 40, and yeah, I know, it's an inefficient antenna, but every time I've tried, I've gotten no contacts, like 0. It's almost as if there's some magical element to this antenna having to be in Japan for it to work. So I did what any sane person would do. I got on a plane, I flew to Shinagawa, Japan, where this antenna was invented, to find out.
Why the seatbelt sign is on. Thank you.
All right, so I got the Gawant here in Shinagawa. Let's see how this thing does. I can't believe I'm actually here. Oh. I left the KH1 charging back at the house. As I was pulling this out of the bag, I was like, this bag's really light. Yeah, the KH1 is light, but not that light. Turns out, if you're gonna go do a park activation, you should probably bring your radio. Oh, it's like an hour to get back. And I don't have that much time today. Okay, well, gonna have to try again tomorrow. Take 2. All right, here we are, 24 hours later. The weather is much more favorable, and this time I didn't forget the radio. I have my KH1 hooked up to the TinyGawant with a 17-foot counterpoise attached to it, running out behind me. So I'm gonna try tuning up on 40 meter and see if anyone comes back to me. This would be a first if I can get a contact on 40 meter with the TinyGawant. All All right, so I have the TinyGawant now tuned up on 40 meter with the counterpoise attached, and I have a pretty decent SWR, at least the radio's not complaining about it, and we got power out, so let's give this thing a try. Well, I've been calling for about 15 minutes now and nobody has gotten back to me. To help rule out if this is a band condition issue, I'm going to switch to a 40 meter coil, which should be far more efficient than this, to see if I can at least wrangle a few contacts and ensure that, you know, this isn't just bad conditions or something like that. So let's give that a try. Okay, so I have the Atom K6ARK 40 meter load coil hooked up. I'm using the internal ATU of the KH1. I've got it all tuned up to like 1.3 to 1, 1.2 to 1. So all ready to go. Let's see if we can get some contacts out of this. So I made 0 contacts with the TinyGawant with a counterpoise on 40 meter and ended up making 6 contacts pretty quickly after using Atom's 40 meter load coil on the KH1 and using the internal tuner. So there isn't really any magic with the TinyGawant having to be in Japan, and while it kind of sounds a little bit like a joke of like, oh, I came all the way out here to Shinagawa just to test the antenna where it was made, the reality is you do tip the odds a little bit in your favor by being in Japan on 40 meter in particular. And the reason behind that is essentially Japan has twice the population of ham radio operators than that of the United States, but everyone is essentially clumped up into roughly 80% of the landmass of California. So NVIS 40 meter is just absolutely hot here. You turn on that spectrum and it's lit up with a bunch of stations. So if this didn't work in the best of conditions with a counterpoise on 40 meter, then I don't think it has many chances of working outside of that. Well, that answers that question. Time to head back home. Let's go. Well, it didn't work. At least I got some Kit Kats. Okay, so in hindsight though, I probably should have tried replacing the whip antenna with, say, a long wire into a tree to at least give myself a little bit more of a chance of making a contact. But I don't know. At this point, I just had to call it and say, let's just keep the 40 meter band option available on the tuner and move on with the design. That said, I don't know, maybe you, the viewer, might be able to make this work. Maybe you can make that 40 meter contact that I haven't been able to make. Now, speaking of you, the viewer, in the last episode, I asked folks if they would be interested in becoming beta testers of the TinyGawant, and the reception was just overwhelming. I got tons of emails and tons of interest, but at the end of the day, I only had 25 beta kits that I could send out to testers to provide feedback for. And I gotta say, I am extremely grateful for all the folks who did get a kit and did provide feedback. I got everything ranging from photos and QSO logs to full-blown reports with how they set up the antenna and sort of methodically went through their testing process. So I took all those improvements, I compiled them into a list, and decided to iterate on the design one last time and make the Rev C version of the TinyGawant. All right, so let's dive into all the feedback items I got from all the beta testers. The first and most common bit of feedback I got from almost everyone who built a kit was that the tune and operate switch here we see is actually really difficult to solder. So I can understand that too, because this switch is actually meant to be pick and placed on and reflowed. And so soldering with a solder iron, if you're not careful, the tip of the solder iron can actually strike the side here and melt the plastic of the switch really easily. It makes sense to essentially replace this switch altogether with something that's maybe through hole and just easier to solder. Now, the second bit of feedback I got was one, that the knob itself is actually kind of a bit loose and wobbly and very, very difficult to tune. I mean, and this is something we saw in the field as well, right? Just even nudging it like this much can shift it many, many kilohertz. And so, this is sort of a known issue that we had talked about in the previous episode. And the idea here in the Rev C would be to add a gearbox to make it, one, a little more sturdy and rigid, and two, to be able to tune this more with some more granularity. The other bit of feedback I got was it was really hard to tell where in this wheel, in this position setting, the resonant frequency is, or where the bands are really along the way. And so, you can look at this little arrow here, and that kind of tells you some indexing, but that's about it. You don't really know where the 20 meter or 15 meter band is. And so adding some labeling to this wheel would significantly help being able to quickly band hop or get to where you want to go, versus playing a guessing game of, well, what switch position am I in and where do I need to aim this thing? So that was another big item that most folks had trouble with and would like to see changed. Another piece of feedback I got, and I actually kind of already knew about this, is that the fact that this whole board here it's kind of hard to see on camera, wiggles around quite a bit. And in fact, when you go to put the antenna on, you kind of have to install it, pull it upwards, otherwise it bottoms out against the case, and then install it in. Now, what would be nice is to redesign this so that it actually has mounting holes and is not relying on the features here to kind of snap it on, because essentially it snaps on and is held in by bumping up against this cap, and it kind of wiggles around, and that's just, we can really improve on that by adding some screws to hold it in place, especially if you're going to be tuning this thing. You don't want it wiggling around. So again, a big thank you to the beta testers for all that feedback. I'm excited to take that input and revise this design one last time. Let's dive into it. All right, so the first bit of feedback I got was an ask to essentially allow the user to separate the ground from the primary side from the secondary side using a jumper. So I threw that in there and isolated the two grounds from one another, essentially giving the user the option to choose what they'd like to do with the grounding scheme. Next, I updated the double pole, double throw switch that folks were having trouble soldering, and instead elected to use a through-hole component that makes it a lot more robust and easier to install and solder on. Looking at the board design, I ended up updating the silk screen to have an arrow that points to the band selection on the main gear knob, and also updated some of the text to be a little more readable. So I have an H now for the high bands and an L for the low bands for the set switch. I also moved the operate and tune switch to the bottom side of the board and kept the ground and SWR LED indicator where they were before. Looking at the back side of the board, because all the components are now on one side, it actually nudged and pushed a bunch of components around, so I had to reconfigure and reroute some of them, but it wasn't too bad. I think it just kind of barely fit. I also placed the jumper pad for connecting the primary and secondary grounds together on the back side, so users can either choose to remove the solder jumper or add it to control the ground topology. Finally, the last thing I added to this design were some mounting holes to make it easier to install the PCB into the enclosure. I only had space to do 3. I would have loved to have added a 4th one, but there were just too many components on this board to make that happen. And here it is, the final version of the TinyGawant, Rev C. This has all our features rolled in. The board looks great. And I've got all the parts right here to solder it together, so let's do that and see how it works. And here it is, the Rev C of the TinyGawant. All the components are now on the back side, and everything just fits perfectly. No interferences, no issues, super easy to solder, especially this tune and operate switch was an absolute breeze. I'm really happy with this. I think the next thing we want to do now is test out the gearbox and see if we can get a good design working here that gives us a little better tunability. All right, so this is the part where I'm going to admit that I forgot to record a bit of my iteration on this design. And thinking through it, originally I actually wanted to make some crazy custom 3D printed thing that would pick up the mounting holes to actually mount the gearbox. And I realized after the fact that maybe it might actually be better to just use these holes for mounting the casing around the Gawant, and to use these holes here that are used to mount the variable capacitor instead for the gearbox, because I'm sort of guaranteed reasonable alignment if I use these screw holes instead of relying on the board mounting holes and the variability and how the capacitor is sort of mounted to the PCB, because there's actually quite a lot of slop that you didn't see while I was installing this. So I took the first iteration of this design and printed it and quickly learned that I got some dimensions wrong. Turns out the capacitor is a lot taller than I thought, and I had a stale model, so I had to go update that model, and then realized with my first iteration of the cover that, you know, one, not only does it kind of look a little funky with this big opening here, you could see the metal tabs of the screw mount, but also I completely forgot to include a little cutout here for the BNC, so this cover doesn't even fit on top of it. Now for the gearbox design, I came up with this little gearbox plate that you can mount directly to the board here, and using the fasteners for the variable cap. And that allows you to install this larger gear that connects to the variable cap, driven by a knob with a smaller gear. This is about a 3-to-1 gear ratio, and so once you mount this all on there, this makes it so much easier to tune than from before where you were directly driving the variable cap. And I gotta say, the gears mesh really, really well. I've normally had to do this process of designing gears manually in the past, and for Fusion 360, there's actually a gear design tool built in. It's one of the plugins you can enable, and boy, did that make it so much easier to design this, and it just fits perfectly and meshes really well together. So I mounted this on and kind of iterated through the design. I also realized that I forgot to put the labels on here, and quite frankly, I didn't really know where all the positions were. So after printing this and testing the mechanism, I then started using an X-Acto knife to sort of scratch in where the various band frequencies are along the gear here. But rather than X-Acto knife scratches, I figured it makes a lot more sense to put some numbers on the gear. I messed around with different font sizes. I didn't want to make them too big because then they take up a ton of space. But if you make them too small, they don't print right. And also realized that based on what your band settings are here, if you want to do the high bands or the low bands. And so I put all the high bands on the outer edge and all the low bands on the inner edge. So once you put this on, and as you're dialing that knob around, you can see it go from like 10 to 15 to 20 meter. And then if you're in the low band setting, 30 and 40 are around here. And it's so much quicker and so much easier to find where you need to actually tune this thing. Now, after tweaking the design a couple times, I was able to get the TinyGawant board to fit nice and evenly onto the back enclosure, and it slides around but doesn't tip or move around, like wiggle like we had before. And then this one took a little bit more iterating, and I kind of wanted to make it look nicer. I don't know if this will be the final design, but it does look pretty good. So what I'm going to do next is install the gearbox and then test this thing out one last time, and hopefully it'll all tune up. Here goes nothing. Oh yeah, that's so much better already. I can feel the difference. Let's see how the gearbox comes together now. Oh yeah, that's so much better. Wow. Oh yeah, that is nice and sturdy now. And the gearbox rotates. Sweet. Oh, this is awesome. This is so much easier to tune. I can get my finger in here and actually be able to switch this, so that's good. Over here as well, easy access. And the thumb screw comes off just fine, doesn't interfere with anything, as with the same with the antenna. All right, one thing left to do, put this on the SWR meter, make sure it looks good, and then take it out into the field one last time. All right, I'm gonna tune it to the 20 meter band, which should be roughly around here. Hey, all right, not bad, 1.5 to 1 on 20 meter. Let's try 15. Sweet, 15 meter looks good. And then 10 meter. All right, 10's looking real good. All right, off to the lower bands. Okay, finally 40 meter. All right, not too bad, 1.38 to 1. I'll take it. All right, I think this thing is ready to go out into the field. All right, got the TinyGawant here. Hooking this up to the counterpoise. All right, LED's extinguished, so we got a good SWR. Switch to operate. Let's get this thing on the air. Washington. Well, the antenna works. $229. There's Gary. $579. All right, 15 meters sounds good. Let's do 10. I nailed the SWR on my first try. Turns out having labels on that gear really makes a difference. North Carolina, 339. All right. All right, so we at least got one contact on 10. Let's try 20. All right, well, for some reason, 20 meter tunes up better without a counterpoise. Just gonna use it as is. Let's see how this does without a counterpoise on. All right, 20 meter, got a contact. That's not bad. No counterpoise too. Hey, it's Mark. Thanks, Mark. All right, 7 QSOs in the bag, barely even trying, and it's time to head back to the lab. Totally works. And with that last field test in the bag, I think it's time to call it. This is the final production version of the TinyGawant. Now, this antenna, while very compromised, does have its place in the ham world. And I can think of 4 reasons why. 1, the antenna has a built-in tuner and SWR indicator, and some QRP antennas don't have either of those. So having something like that already built in, not having to bring extra stuff with you, is actually kind of cool. The other nice thing about it is it takes up almost no space. If you want to set this antenna up, you don't have to put up a tall mast and a counterpoise even, as we've learned, though it helps. But that means you can operate in a very small footprint. And there are places, there are summits especially, where you don't have much of a place to set up a big antenna. So something like this actually is not such a bad thing to bring with you. Now, one thing I should mention is that at the time of this recording, it is the peak of solar cycle 25. And so it's a great time to experiment with less efficient antennas, more compromised systems. And it's kind of fun to build. Now, there's one feature about this that I had not considered up until just very recently, which is it actually makes a good receiving antenna. You can actually tune across all these bands and even shortwave bands, and the antenna works great. You can receive stations from very far away, and I've actually even used this to sniff out RFI throughout the house. So it has its use cases. It's just, don't expect to be working crazy DX with it. And frankly, the performance of the antenna actually made me question if I should even make this a product and sell it. And originally I was going to make it an assembled unit that you could buy, but sort of compromised on making it a kit instead. So I figured I'd get at least a few boards made, kit them together, and have folks build them and have fun experimenting with them. Now, if all of those things sound good to you, I've decided to open source the entire project so you can download the board files and the 3D print files to build one on your own, or feel free to iterate on it. And I'm also going to be making a small batch of kits available on my store, n6ara.com. If the product starts to sell really well, I'll make more kits. Just check the website for status. I gotta say, what a journey this has been. I did not expect to fall into the YouTube rabbit hole. I originally started this channel to try to document my original thought of creating a TinyGawant antenna, and that quickly evolved into 3 episodes, each which are like roughly 45 minutes long. So if you stuck around and watched all 3 of these episodes and enjoyed them, thank you so much. This has been a ton of fun for me and has just opened the door for me to share more products and more ideas that I have with you. So if you're enjoying the content here, please help me grow this channel and hit like and subscribe and share it with your friends. It really helps a lot. Anyway, that's it for now. Thank you so much for watching, and 7-3.
This thing's receiving like gangbusters. Dude. This is a great antenna.
Why isn't this thing working? Ah! Take 2. That's our latest subscriber. I don't know who that was actually.